So, so anyway, my name's Jeff, and I currently am a mentor for Team 5148. I work for GE Healthcare, where I am the test equipment architect for MR products. And I currently mentor 5148. This will be my 18th season as an FRC mentor. This is my fourth team as I have moved around the country. So, and then if there was a Wisconsin regional this year, I would be the lead robot inspector. And I've been a robot inspector since 2007. And in the 14 years that I have been a robot inspector, I have volunteered at over 35 events, of which over 20, including championship divisions, I was the lead robot inspector. So basically what that means is I've seen a lot of creative things, and some of which are good, some of which make for a bad day for all of us. So purpose of this presentation, well, first off, is so that I don't get the look that you see there with my friend up in the corner. This is great. Zoom will not let me take control of the presentation. There we go. So what we're going to do here, and I'm going to take the hat off. But anyway, when you get to an event, if you're new to this, you'll see people running around in the bright yellow or green hats, and that signifies that they are functioning as a robot inspector at the event. So if you have a question related to inspection or related to your robot, don't grab anybody just in a volunteer shirt, grab somebody in one of the hats. So what we're going to do here is we're going to discuss some of the most common problems we see every year during inspection. In order to avoid you having these problems and get through and have a fabulous event experience. We always start this presentation with a note that the only constant in FRC is that nothing is constant. The rules change every year. Every year I have to have at least one discussion with somebody that says, but it was legal last year. That means nothing. So in general, I don't refer to specific numbers anywhere. We're going to make an exception this year because we already have been told by headquarters that size, weight, starting configuration, and most other rules will be the same as they were last year. But again, every year, we're basing this on our best guess because the rules come out at kickoff. And no matter what I tell you today, what comes out in the rule book at kickoff takes precedence over anything that I say. And more importantly, and this gets at least one team every year, during the season, at least in a normal season, we don't know what we're going to do this year, but there's a team update that comes out every Tuesday and Friday after kickoff during the build season. Those are official rule updates. They can change the rules or supersede the rules. And I can't count the number of times I have been at an event and had, generally a mentor pull out a binder out of their toolbox and point at a rule, and I point at the bottom of the page and it says revision 0, January 5th. And I go, you do realize that we're up to revision G of this document. And then I get the look that my friend had there on that first slide. And we want to avoid that. So that's important. If you're a rookie team, or even if you're not a rookie team, I always recommend that you assign 1 or 2 responsible students to read those updates every Tuesday and Friday and pass along any relevant information to the team. I also recommend that the mentors read them anyway, just because. So anyway, here's the first update that we know of for this year. This used to be a big long slide that talked about all kinds of good stuff about the bill of material. And fortunately this year I can say you don't have to have one. I'm conflicted on this some ways, but it's a headache for most teams that is gone this year. It's not guaranteed to be permanent. They, headquarters has said they will evaluate how this works, and it may come back. One of the key reasons for the bill of materials in the past has been to help us enforce the rules relating to overall cost of the robot and individual component costs. So if you show up to my event with a robot with a laser ring gyro on it, you're going to have to prove to me that anybody can buy that for less than $500 or whatever the limit is this year. Even though you don't have to put the documentation on the bill of materials anywhere, it doesn't mean you can go buy whatever hideously expensive part you want, or have a sponsor give you something that no other team can buy for less than $500. So moving on, this is probably one of the two biggest issues that we run into every year. There is a weight limit to the robot, contrary to what some teams seem to think. I've had teams show up with a 200-pound robot. The only way to fix a 200-pound robot is with a Sawzall. That may, we want to avoid that experience. I can tell you that it's much, much easier to manage your weight while you're doing the design and the build than it is to go back and try to figure out how you're going to get 2 pounds out of your robot once it's done. Everybody says, well, we'll just show up and we'll drill some holes in the robot when we get there if it's overweight. First off, you have to drill a lot of holes, or they have to be very big holes. If you hand some freshman a drill with a 1/4-inch drill bit in it and tell them to drill some holes in the robot, a couple things are going to happen. One, they're going to drill through some wires. 2, they're going to get shavings in the control system. And 3, they're not going to be able to drill enough holes. When I do this in person, it's always interesting to let people guess how many 1/4-inch holes you have to drill in a piece of 1/4-inch thick aluminum to remove 1 pound of weight. Since we can't do that poll here, I'll just tell you, it's over 700. So obviously, you're not going to hand somebody a 1/4-inch drill and remove 1 pound of weight from your robot. Every year we have somebody show up thinking that's what they're going to do, and we end up handing them a hacksaw. It's much better to manage this up front. If you think you're going to need to drill holes in something, drill the holes in it in a nice organized fashion where you're not causing stress issues or the like up front before you assemble the parts. It's really hard to get a gearbox back apart to try to do weight relief on the gears once it's buried in your robot. Assign somebody to track the weight. Have a weight budget. My teams, every year we have a weight budget, and the lead mechanical or system engineering student is responsible for tracking and enforcing that. So we might say, okay, the drivetrain gets 30 pounds. The manipulator gets 25 pounds, and then we always hold back 5 or 10 pounds as what we call an industry engineering reserve or management reserve. It always ends up on the robot, but the kids have learned they'd much rather go negotiate with another sub-team lead than to try to get me to give them part of that 5 pounds of allowance that we've held back. In some years I've been lucky that 5 pounds has turned into a barbell plate on the bottom of the robot that lets us set our center of gravity where we want it. But if you have a weight budget and a plan up front, it helps considerably. Hopefully you're CADing your robot. Set the material properties in your 3D CAD software, and it will tell you pretty accurately how much it weighs. The one where teams get burned on this one is because you never CAD the wire in the robot. There's 7 to 12 pounds of wire in the typical robot. Make an allowance for that in your budget. Wire is not weightless, and that adds up for people. They don't expect it. If you, for some years you've wanted to be at maximum weight for one reason or another, It's far easier to have a plan to add a pound or two to your robot at the event than it is to try to figure out how to get your robot that's 2 pounds over down to weight. And the advice I give to teams, especially rookies, is buy a good scale. You can get a good one for less than $150 from somebody like Grainger. You know, whenever teams show up with a weight problem at the event, invariably they either haven't weighed the robot or they're trying to weigh it on something like a bathroom scale. You know, just like you're going to buy drills and saws and all your other tools, buy a good scale and consider it an important tool. This is the other one that teams seem to forget. There is a size limit. And speaking of things that constantly change in FRST, you know, as you can see, there have been several changes over the years. For this year, we know that we're back to frame perimeter definition, and that it needs to be less than 120 inches frame perimeter. So this is the next question I always get is, what is a frame perimeter? So if we go here, if you look at this black line here, oops, nope, that's not what I wanted you to do. You can see here where it says robot frame perimeter, and it shows this black line. That's the frame perimeter. Basically, what you do is if you were to take a piece of string or a fabric tape measure or something, wrap it around the robot at the frame at the height where your bumpers mount, that is how you measure the frame perimeter. Oops. Stupid computer. So, because there's always some confusion among teams too on how we measure the frame perimeter. So it's, if you wrapped a string around it, it does not include indentations in the frame. That was the other reason I wanted to bring that one up. So like right here where it shows, where it shows this notch in the robot, you do not measure around the inside of that as the frame perimeter. The frame perimeter is the imaginary line that goes from here, this corner to this corner. That one always seems to confuse some teams. You know, to be safe, I always recommend that you aim for at least an inch under size. Just in case you have one of those Harbor Freight tape measures that doesn't quite measure right or doesn't measure the same as my tape measure. Every year we have somebody that shows up exactly at the size limit, and then we go, oh, you got to put a guard on this, or you're missing something or whatever. Then all of a sudden they're too big. So give yourself a little bit of margin. This is another one. Robots can be rechecked at any time, so make sure you don't have it get bent out of shape. Fortunately, we no longer have the sizing box, but there was a time years ago where we would put the robots back in the sizing box before eliminations, and it was amazing how many robots didn't fit that fit a day and a half earlier. This also can be an issue if you go to multiple events or if you practice with your robot in between events or whatever. It may get bent out of shape, and just because it passed inspection at the first event doesn't mean it will fit. This is the other one that seems to be getting a lot of people confusion. The rule says minor protrusions less than a quarter inch are allowed in the bumper zone. Basically, that means you can have bolt heads or nuts sticking out of the frame behind your bumpers. It doesn't mean that 4 feet in the air, you can have a mechanism that hangs out a quarter inch. Okay, so bumpers. This would be the other reason teams have inspection issues. And I could talk for about 2 hours just on bumpers, but we're not going to. You know, I say follow the requirements shown in the current rules. However, I will be the first to admit that what is in the current rules is less than clear. So not going to go into great detail. If you have questions on whether or not your bumper construction or your creative bumper idea is going to be legal, just shoot me an email, send me some pictures. But these are the things we run into all the time. 3/4 inch, not 1/2 inch, not 1/4 inch, plywood or hardwood, not particle board, not OSB, etc. And so a word to the mentors out there, when you send some, because it seems like a lot of teams send some freshmen off to build some bumpers, double check what they're using, because every year we have somebody show up with plywood that's too thin, or with with wafer board. There's a reason for the requirement on the piece of wood, and it is to keep the bumpers from breaking. As these robots have gotten heavier and more powerful, we are seeing bumpers getting caved in and broken during competitions, even when they're built to the rules. In fact, I saw a set a couple of years ago where not only did they crack the bumper, they caved in the frame rail behind it. It wasn't even unsupported. So, and I've had teams that think, okay, well, we're going to just wrap the fabric around it, and they'll never know we used 1/2 inch plywood. I pick the bumpers up and I feel the wood, and I can tell that it's too thin. The other dead giveaway will be, I know what a set of bumpers weighs, and when you throw them on the scale and all of a sudden they're 4 pounds light, that will invite further investigation. So will if they're 4 pounds heavy. Some of the years where we've had where you wanted to be at maximum weight, we've had teams do creative things like put a piece of rebar inside the pool noodle. You can't do that. Covers need to be attached well, and the covers need to be one solid color. The purpose of the solid color requirement is so that it's obvious to the observers on the field, to the other teams that are scouting or whatever, which alliance you're on. So if you've got reversible covers and you've got a little tiny bit of the other color showing, we'll probably let that go. But it can't be really difficult to tell. And they need to, approximately match the colors in the first logo. If your blue looks black, if your red looks orange, we're going to not be happy about that. We might let you play at your first event. If you're going to another event, I guarantee you I'm going to take a picture of it, or the LRI is going to take a picture of it, and we're going to send that picture to the LRI at the next event. We've had some teams that are trying to be artistic and be closer to their team colors, which I understand that, but the rules do say it should be very close to the first logo colors. Bumpers have their own weight limit. They're weighed separate from the robot, and this is the next one, must be rigidly attached to the robot. People ask me, how do I define rigidly attached? We need to be able to pick the robot up by the bumpers. You can tell me, well, we never do that. I don't care. That's how we define rigidly attached, for two reasons. One, if somebody gets underneath your bumper out on the field, and all your bumper does is hooks over something and isn't attached, it will pop up and fall off, and then the ref's going to reach over and hit the disable button. The other thing would be that you may never plan on picking it up by the bumpers, but When the field reset crew is yelling at you to hurry up and get the robot off the field, sooner or later somebody may grab it by the bumper. This is an important one. If you're using the kit frame with the Andy Mark brackets, pay very close attention to the instructions, because it's very easy to mount the bumpers to the frame using the brackets such that it doesn't meet some of the rules. Bumpers are required to be supported. You need frame at the ends, and you can't have more than 8 inches of unsupported bumper. Again, that's for those cave-in reasons. And then when it says frame structure, it needs to be something structural. You cannot take a piece of 40 thousandths polycarbonate and stretch it between 2 standoffs at the ends of the robot and try to tell me that's your robot frame. Again, the purpose of this is to keep the bumper from being able to flex in too far and cave in. Pay close attention every year to the bumper zone height requirements and to the minimum bumper length. And that would be, this is an important thing to note, is, like this year, the requirement is that the bumper has to be at least 6 inches long. There's always some misunderstanding on how you measure the 6 inches. That 6 inches is not from here to here. We always have teams that show up because they're trying to maximize their ball intake opening in the frame. So they measure the edge of the bumper and say, well, this is a 6-inch bumper. The length of the bumper is measured here with the amount of bumper on the backside that is along the frame perimeter. So your 6-inch measurement needs to be, the length of the piece of plywood from the corner, not the outside length of the pool noodle. The bumpers have to come off the robot for size and weight. The rules have this hilarious guideline in them that bumpers should be removable, installable by one person in less than 5 minutes, 10 minutes. Every year we've got some teams that it takes them an hour to put the bumpers on the robot, and that's a problem, in that it makes inspection very hard, and other things. Now teams that swap especially if the teams are swapping bumper colors between matches, if you're going to swap your entire set of bumpers, they need to come off and go on very quickly. If you just have to put them on once, it's okay if it's going to take a little longer, but it still should not take you an hour. The other important thing here to note is that bumpers are one of the most visible parts of your robot. You can have a beautiful looking robot and then have horrid looking bumpers that have flaps of fabric hanging everywhere, pool noodles showing out in the corners, fabric dragging down on the floor, and it makes your whole robot look bad. Especially now that we don't have to bag the robot up and that you have access to the robot all the way up to whatever competition happens. There's no excuse for showing up at the event with a pile of parts and trying to make bumpers and figure out how to attach them to your robot. The other thing that I mentioned to teams, and my teams have done this frequently in the past, basically first is giving you the opportunity to bolt a piece of 3/4 inch thick plywood 5 inches tall to the side of your robot. That makes an incredibly strong structural frame member. So if you're having issues with weight, evaluate how you can take some weight out of the frame behind that, knowing that that frame only has to be rigid enough to keep the bumper from caving in and to support your robot long enough to put it on the scale. And then you can take it back to the pit and bolt that plywood beam to the side of it. I know a couple of years ago, my team's robot was running 3 or 4 pounds overweight, and we cut out huge portions of the frame rail because we could bolt what was left into the back of the bumpers because they didn't have to come off. And basically the bumper became the frame once it was assembled to the robot. So look at your bumpers holistically as part of your overall design. Bumpers should not be an afterthought. Bumpers should be an integral part of the design of your robotic system from the beginning of your design process. So I'm going to pause here for a second. Are there any questions up to this point? Okay, well, moving on then. Sharp edges. I've never inspected a robot I couldn't find a sharp edge on somewhere. That said, we don't go out of our way to look for sharp edges. So as the words and the rules say, we're looking for ones that could cause injury. We're looking for pinch points, entanglement, and impaling projections. I'm not going to dig down around in the middle of your robot where nobody's ever going to put their hand. At the outside of the robot. And then what I tell my inspectors is, from an ergonomics standpoint, ask them how they pick the robot up, how they grab it, and watch when the team members go to lean into the robot to pick it up, because naturally, and this is easier to show when I'm in person with a robot, when you bend over to grab the robot to pick it up, naturally your head leans in. Make sure there's no small, sharp things pointing out that's going to stab somebody right in the middle of their forehead. Look at where they say this is where we grab the robot to pick it up. Okay, double check that for sharp edges. Where's the main breaker? How do we reach the main breaker? How do we reach the pneumatic dump valve? Well, the main breaker is right here through this hole that we melted through this piece of polycarbonate with our dull Dremel tool that has big jagged edges on the backside of it. Okay, well, somebody's going to reach in there, and your team members might know, hey, we got to watch out for the sharp edges. But when your robot's in flames on the field and the FTA has to run out there to turn it off, he doesn't know that. So we're going to make you deburr that hole. Same thing. Show me how you take the battery in and out. Show me how you reach in here to do this. We're going to pay careful attention to where your hands are going on a regular basis into the robot, often when you're in a hurry, for sharp edges. As I say, cut plastic edges. One of the easiest ways to make a nasty razor sharp edge on your robot is to take that Dremel tool and try to melt a hole through a piece of polycarbonate for some reason. My number one pet peeve on robots would be zip ties. Cut them square, cut them flush, take a file to them, I don't care, but don't snip them off, leaving a 1/4 inch sticking out, cut at a 45-degree angle. You're just asking to add weight to your robot with all of the blood that's going to end up in it. And since one of our major goals as volunteers is to make sure that all of the students go home with the same amount of blood they came to the event with, we don't like that. Please, if you don't have something that cuts them flush, buy that would be the second thing I tell teams to buy after a scale, is buy a few sets of $4 flush cutting nippers. You can get them cheap off of Amazon. Consider them disposable. They break, they wear out. There's a reason they're $4. Don't buy one set and expect it to last multiple seasons, but buy some. The other one would be watch out for screws. In particular, so like last year, my team built our robot out of plywood. So there's some wood screws in it. Well, if you use a wood screw that's too long, that leaves a really nasty sharp point sticking through the backside of whatever you put it on. So just watch out for those things. Team numbers, believe it or not, we fail a lot of teams for team numbers. They have to be visible from all 4 sides of the robot. This is where what gets teams is the rules specify a height and a stroke width. So, if the rules say 4-inch with a 1/2-inch stroke width, then 2 inches tall with a really fine line that you drew on there with a paint pen isn't going to do it. Numbers are important. This is how the announcers identify your robot. This is how, importantly to your team, this is how other team scouts identify your robot, and this is how the judges identify your robot. So, the number is important. You need to get it on there. It's your team's identification. Be proud of it. Don't do creative things. Don't try to take a 0 in your logo and make it look like your, round Warrior Bots logo there. We've had teams try to do that. No stylized characters. Some years there have been rules regarding whether or not you could split the number, like, can I have a 5-1 on the left front bumper and a 4-8 on the right front bumper? That has changed at times over the years, so pay attention to that on a yearly basis. It used to be that you were required to have the name of your school or sponsoring organization and your primary sponsors on the robot. That's no longer required, but this is kind of like NASCAR. These are the people that helped you raise the thousands of dollars to pay for that robot. So 1, you should be proud of them and give them the appropriate credit. But 2, you should make sure that you put their logo on the robot in a way that identifies, respects their branding. Don't take a sheet of paper, run it through the laser printer, and just print out in words the names of your sponsors. They have logos, they make those files available, etc. And then this is the other thing that I tell teams is try to build a robot that those sponsors are going to be proud to have their name identified or displayed on. Let's see, moving on, electrical. There's a whole presentation on electrical, so I'm just covering the things that get teams in trouble. The battery must be securely fastened in place, irregardless of the orientation of the robot. So that means if I turn your robot upside down and shake it, the battery needs to stay put. That means that you got to have something over the top of it. It's got to be clamped somehow. What goes over the top probably shouldn't just be one loose bungee cord. Every year we see robots dragging batteries around on the field. This is bad for a couple of reasons. One being you're now violating the frame perimeter rule and you're going to take some penalties. 2 being it's a good way to start it on fire. Insulate your battery terminals. So you can see here in this picture, they've got good insulation all the way up around the battery terminal. You should not be able to see any metal. However, that's not the reason this picture is here. Do not modify your batteries. This team had what they thought was a great idea. As you can see here, they drilled holes in the top of the battery so that they could put handles on them. I appreciate the idea. It violates the don't modify the battery rule. And I hate having to tell a team that they now have 6 very expensive practice batteries. The rules have a list of rules on the size and color of wires. All I'm going to say is please follow that. One of the things that makes me very sad as an LRI is to have to tell a team that they have to pull all the wires out of their robot because they're the wrong color or the wrong size. Only use the allowable types and numbers of motors as specified in this year's rules. I think last year was the first year in a long time I did not see a globe motor in a robot. For anybody that's been around for a long time, those used to come in the kit of parts. They haven't come in the kit of parts for at least 5 or 6 years. But older teams still have them laying around. People pick them up, put them in the robot. Awesome motor. I love them. Wish we could get them again, but we can't, and they're not legal. So what FRC has announced so far for this year is that the motor list is the same as last year, with the exception of there's 1 new motor from REV which is a small 550 size robot or motor that's typically used in FTC that will be added to the list. And then don't do this. I apologize, it's not a great picture. My phone didn't focus well, but they made their own battery cable. Couldn't get the wire in the terminal they were trying to use, so they snipped off about half the strands. Don't do that. Electrical system's got to be isolated from the robot frame. This is easy enough for you guys to check as you're building the robot. Take your ohm meter. Every team should have an ohm meter. Unhook the battery, close the main breaker, and measure from both battery terminals to the frame. Okay, this one's not a rule, but we recommend that you label your circuit breakers in the PD, label the wires, so that when the wires fall out, you know where they should go back in. This is a rule. Mount the PD so that we can see it for inspection. We need to check what size wires are connected to what breakers and what size breakers are connected to what motors. If we can't see it for inspection, this is a problem. We have made teams move them, or I can make you take the robot back apart even, so we can get to it. Not going to worry too much about the radio this year, because we'll worry about that if we actually get to have events where we get to use a real field. But just make sure you're using the right radio. This is one that teams run into problems. Pay attention to the instructions on how to hook it up, because it needs a certain amount of power or it will flake out, and mount it so that we can see it. And you need to program your radio at each event. Just because you programmed it at the event 2 weeks ago doesn't mean it's got the right security key in it for this week. They're regenerated every week. The other one would be for rookies or new teams. Once you take the robot to an event, when you get it back to your school, it's not going to work. You're going to need to reset the radio so that you can clear out the encryption key. Pneumatics, and I know we're getting close to 10 minutes left. Compressor not operating right is one of the most common problems that we see for failing teams. You gotta hook it up to the pneumatic control module, or you can use one of the old spike relays. You cannot wire the compressor directly to the pressure switch. Yes, it works. It works for a little while. It will not work forever. The compressor pulls 15 to 25 amps at compressor startup, depending upon the compressor. The little micro switch that is in the pressure switch is rated for 1 amp. Eventually it will fry. The other reason for this being that when we disable the robot, the air compressor needs to disable. And if you wire it directly to the pressure switch, then we lose that safety factor. Compressor must shut off at less than 125 PSI. If it's going higher than that, you can double check your gauge, or you may have a bad pressure switch. If you're using the PCM, the compressor is enabled and disabled by CAN connection between the RoboRio and the PCM. You can't just hook it up to that. You have to instantiate at least one pneumatic device in your code in order for the underlying software system to enable the compressor. And then, the rules on these have changed over the years. So don't use any more than the number and type of storage tanks allowed in the rules any given year. There's a overpressure relief valve that is specified in the rules. You got to attach this directly to the compressor. This cannot be at the other end of a few feet of flexible pneumatic tubing. The reason it's there is because if something goes wrong and the compressor runs full time, we don't want to overpressurize the system. And if the compressor runs too much and gets too hot, we have had the plastic pneumatic tubing melt, which is why we don't want the overpressure valve downstream of that. There are minimum pressure ratings given in the rules. These have changed a few times over the years. So I just say it's got to meet whatever the rules. And then this is an important one. Do not modify any pneumatic component. Basically, the only tool that should ever touch a pneumatic component is the wrench that's the right size to screw the hose attachment fitting into it. If you're touching a pneumatic component with any other tool, stop and ask yourself why, because you're probably in violation. This includes painting. You cannot paint the pneumatic system components. The reason for that is if you painted it, I have to assume that you're trying to hide damage. And we have, as LRIs, we have zero leeway on these pneumatics modification rules because this is driven as a safety issue. If you painted your cylinder, I'm sorry, you're going to have to replace it. I've had teams drill out the orifice on the unpressurized side of a cylinder because they want it to vent faster. Yeah, I know you're not putting any pressure on that side, but you've modified it, et cetera. So basically the rule there is if you're touching a pneumatic component with a tool, other than a wire cutters to trim the wires on a valve or the wrench to screw the fitting into it, you're probably in violation. Firmware version, you always have to make sure you have the latest or the correct version. And in general, the version at kickoff is probably not going to be the version that will be in use by the time the competitions start. So kind of to summarize here quick, and then we'll get to questions. There's an inspection checklist released every year. Go ahead and get a copy of it and try to pre-inspect your robot. When we get to your pit to inspect your robot, we tell the inspectors to only talk to students. First thing I do is throw all the mentors out of the pit. I will only bring a mentor back if we have a major issue that I want to make sure that they understand what I'm telling the students the issue is and what they need to do to resolve it. So make sure you have team members that know the answers to the questions. This is the other one that gets us all the time is a team will come up right before lunch, say, we're ready to have our robot inspected. Okay, next inspector will be over in a few minutes. The inspector will get over there in 10 minutes and find out that the only person left in the pit that the team didn't take out of the venue to go to lunch is the website developer. That's not going to be an inspirational experience for that poor student. Make sure you have students available for inspection that know the robot and know the systems. Contrary to popular belief, the inspectors are there to help. If your robot has a problem, we're going to try to help you get it fixed. We're going to try to find you another team that can assist you. We're going to get you the help. We're not out to fail teams. As the LRI, I take it personally if there are any teams that miss a match because they haven't been able to get through inspection. I feel I have failed if that happens. But we need to make sure that you're legal. We need to make sure that you're safe. And we need to make sure that everybody's playing on a level playing field. Now, that said, that we're going to try to help you guys. Please help us out. Don't wait till 7:30 on Thursday night to get in line for inspection. To do inspection right takes us 30 to 45 minutes. If I know that you've been wasting time all day and you show up at the last minute, we're not going to rush your inspection. I assume that if you pull that, you're trying to make sure we miss something. At this point, I don't feel bad if you miss your first match. We will run your inspection into Friday morning. Now if you've been frantically working all day trying to get the robot done, or fix a major issue that we found, that's a different story. But the other thing is if you show up 30 minutes before inspection and that's the first time your robot gets on the scale, or that's the first time we take a tape measure to it and we find out you're oversized or overweight, we have no recovery time. So please, please, please do not think you have all day Thursday, especially now that there's no bag. The build season runs right up to the start of the event. There is no reason to show up at an event with a robot that isn't ready to start inspection by noon on Thursday. So if an inspector is telling you something that you don't agree with, please politely and with much gracious professionalism ask to get a second opinion from the lead robot inspector at the event. The inspectors will not be offended. They know that that's what we ask teams to do. And unfortunately, when I and my cohorts agreed to be lead robot inspectors, we recognize that means that we are agreeing that we may have to be the person that has to deal with some issues that need to be resolved. But that said, we try to train our inspectors very well, but I know that there are things that they're not experts on or that they may miss. And one of the reasons I got into inspection in the first place was due to a thing where an inspector told my team long time ago that something was wrong, and we basically rewired the entire robot to fix a problem that wasn't a rule violation. So nobody will be offended if you ask to get a second opinion from the lead robot inspector. The last few things here: don't rationalize what will never happen. Make your design safe. If you have to start trying to rationalize a safety issue in your robot, it's not safe. Please back up and reassess that. Don't plan on debating your way to an inspection sticker. I'm not a lawyer. I am an engineer, but I will. If you think you have a creative interpretation of the rules, that you're going to try to bend the rules farther than I'm willing to bend them, again, don't think you're going to debate your way to a sticker. And this one is important. This is in the manual. Decisions of the lead robot inspector are final. So if you ask for a second opinion and the lead robot inspector comes over and tells you no, then that's it. Now, understand that before I tell you that you need to that something's not legal or your really cool design feature is illegal, I'm doing everything I can. If it's not explicitly illegal by the rules, then we allow it. We're not looking for how to make things illegal. And then, if I'm not sure, I've been on the phone. I've already been on the phone with the chief robot inspector. I've possibly been on the phone with headquarters. We have access to all of those people. So if the lead robot inspector comes over, looks at something and says, I need half an hour, I'll get back to you. That's what we're doing. We're trying to figure out some way, some creative interpretation of the rules that we don't have to make you change something. But if I walk up and say that's inherently unsafe and it's not legal, don't go complain to the regional director. Don't go looking for the head of the planning committee. They're going to tell you, don't go to the FTA. They're all going to tell you the same thing. What did the lead robot inspector say? And just know that we are going to do everything we possibly can to make sure your robot passes inspection. To the point where I've had inspectors in pits helping teams rewire the robot, etc. We will get you help. We will get you parts. That said, if you have a problem at an event, you need parts, you need something, you're not sure, come talk to us. We've been in all the pits. We know who has what. We know who has what tools. We know who has what spare parts. We've also been around for a while. We know which teams are good resources. We all mentor teams. We're there to be your friends. I don't want to be anybody's enemy. I know we're right at the end of time. Oh, I guess that was my last slide. Are there any other questions before I let everybody go back? Otherwise, as I said at the beginning, once the rules come out at kickoff and we know a little bit more what's going on this year, we'll host some more sessions. To be honest, I hope I get to look at some robots in person this year, but I'm not optimistic that we will have any events where we actually have to inspect a robot this year. Okay. Any questions before y'all pop back to the main session? Okay. Thank you for your time and for putting up with me.